Hi everyone. Today we're going to be looking at solving linear inequalities. Now we're going to look at doing this in two separate ways, and that's by hand and also through a graph. Now the reason you'll also be doing it by a graph is because linear inequalities, so ones that just have x instead of things like x squared or x cubed, is because they are the only ones that can actually be solved efficiently by hand. Every other inequality needs to be solved using a graph. So we're going to look at both methods today. Now, when it comes to solving inequalities, you do treat them the same as equations, but there is one little twist if you have to divide by a negative at any point. Okay, so we're going to go through that. Now, what makes this an inequality is, of course, that less than or the greater than sign, less than or equal to, they're all inequalities instead of an equal sign being an equality. Okay, now we do follow very similar steps that you would to just solving. So having a look at this one here, wanting to get x by itself, I'm going to start by adding 7 to both sides, which means that 2x is less than 12. Okay, after that, I'm going to divide both sides by 2, and I end up with x is less than 6. Now, I can check that out by going, okay, well, if I sub in, let's say, 7 into that inequality up there, is 2 times 7 minus 7 less than 5? Well, no, because I've got 14 minus 7, and we know that this here is false, okay? Whereas if I went and subbed in 6 or 5, it would still kind of match up, okay? Now, once again, same thing here applies, but I've got variables on both sides. So up to you how you approach this. But I'm going to start by subtracting 3x from both sides. And that's going to give me 4 is greater than or equal to 2x minus 9. And I'm then going to add 9 to both sides, giving me 13 is greater than or equal to 2x, which means that if I divide them both by 2, I'm going to have 13 over 2 is greater than or equal to x over 2. Not x over 2, I apologize, just x. And if I wanted to read that as x is something, I would then just swap it around. So it'd be x is less than or equal to 13 over 2. And those two mean the same thing. Now, dealing with a fraction, same sort of step here. I'm going to multiply by 3 on both sides. That's going to give me 2x minus 4 is less than or equal to 3x plus 7. If I then expand those brackets, I'm going to have 2x minus 4 is less than or equal to 3x plus 21. Now, what I'm going to do here is to keep it on the left side, I'm going to subtract 3x from both sides. So that's going to leave me with negative x minus 4 is less than or equal to 21. And then I'm going to add 4 to both sides. And that's going to give me negative x is less than or equal to 25. Okay, not quite the way I want to read it. I'd rather have that as just an x. So what I'm going to do in this situation is I am going to divide by -1 on both sides. But what that means is I'm going to have to flip this sign here. So I'm going to be left with x is greater than or equal to 25. Now, if I was to sub that into the above and I had -25, that would still work in this situation. If I was to sub in 30, let's say, I'd have -30 is less than 25, which we know is true. So whenever you have to divide by a negative, you do have to flip the sign the other way around for it to still be correct. So let's have a look at solving this linear equality here by graphing them out first. What I've got here is two separate linear equations. I've got y equals 2x minus 3 and y equals 5. What I'm going to be doing here is graphing these two and then finding that point of intersection. And in this case, finding where y equals 2x minus 3 is lower than y equals 5. So let's start by graphing y equals 5. We know that every point of y equals 5 would be x 5 because it's saying no matter what I do to my x, my y is always going to equal 5. So if I draw a line straight across here, that would be my y equals 5. Now, if I wanted to sketch my second graph, my y equals 2x minus 3, I know that my y-intercept is at 0, -3, which is just here. I know that my rise is 2 and my run is 1. So for every 1 across, I'm going to go 2 up. Every 1 across, I'm going to go 2 up, and so on. Okay? If I connect those up, I'm going to end up with the graph looking a little bit like this. So we've got a very clear point of intersection. Now, our point of intersection is going to be right here. And all of this area before we get to that point of intersection, if I shade this whole area in, matches that inequality up the top, because that's the point at which that blue line is lower than the 5. Now, I need to figure out this point here, which is where they cross over and the blue line starts being above the green line. And that point there is going to happen at 4, 5. Okay, with y being 5, that makes complete sense. Now, we need to be really careful of this sign here, because it can be less than, or it can be less than or equal to. In the case of it being less than, this line should actually be a dashed line. And if I make it a dashed line, that's just showing that it's not equal to whatever its point of intersection will be. Now, that means for this one, my answer would be x is less than 5. Okay? And this applies for any graphs that you do. Now, you're not always going to get something nice like y equals 5. You might end up with something like this graph here. Now, this inequality that we're going to work with, instead of having just something like y equals 5, we've actually got two very distinct graphs with distinct y-intercepts and gradients. So it's really important that we find this crossover. Now for this one, because of that less than sign, I really want us to practice drawing that dashed line instead of a full line, okay? So I'm going to call this one here my y1, and let's call this one here my y2. Okay, so my first equation is going to be y equals 3x plus 1, and my second equation is going to be y equals 2x minus 5. Now, they've both got a positive gradient, which is great. This one here is going to have a y-intercept of 0, 1, and a rise of 3 with a run of 1. So I'm going to plot that y-intercept at 1, and I'm going to go across 1 and up 3, across 1, up 3. And I'm going to connect this line with a dashed line, because I'm working with that less than rather than that less than or equal to. Now, y equals 2x minus 5, I'm going to have an intercept at 0, -5. And I've got a rise of 2 and a run of 1. So I'll be going across 1, up 2, across 1, up 2, and so on. Now, if I do this, I will end up intercepting at some point. Now, these were drawn really badly. However, they will end up intercepting at a point which for this one you can find by solving by hand. But if you were given a calculator or a graphing tool, you could use that to then find their point of intersection.